this, we've looked at diagrams like this before. We looked at CD was in fact the chord. Okay, that's the segment. All right, that's the segment with the endpoints on the circle. Okay, so CD is the chord, whereas CD is the arc. They still have the same endpoints, but they're just drawn up differently. Okay? Remember that arc has a curve to it, whereas the chord is a segment. Okay? It's a very simple thing to think about in that case. All right?
I don't.
I'm fine. Just a little dry. So what's going to happen here is that chords intersect arcs. All right. What that means is that the chord has endpoints that an arc also shares the endpoint of. Does that make a little bit of sense? To think about it. So I can do another one here. If I have, we'll call this E F. That chord EF has an arc EF as well. Chords create arcs. Right. Just like we had diameters. A diameter did what to a circle? Do you remember? Split it in what? Half. So the diameter split a circle in half. If you think about degrees then, it split the diameter, split the circle into how many total degrees? 180. Okay, so that's how this stuff works. So we get it going into these things. Now, what we do with these, oh, real fast. Do you remember what a major and a minor arc was?
Major arc was overlay.
Minor? How many letters do you usually have for both? Which one's 3? Major, why? Because there's more, because it tells you what direction you're going. Okay. Whereas when you see 2 letters, what happens? Where do you always go? Yeah, you want to say straight, but it's shortest distance. That's just a quick little reminder of that one. So what happens here then is that in order to have arcs and chords, and this is kind of weird, if 2 chords, excuse me, 2 arcs are congruent, if their chords are congruent. Sounds really weird. But what happens is 2 arcs are congruent if the chords are congruent. If I'm looking at this scenario, you'll see this more often within one circle, and I'll show you an example of that here in a second. What happens is, if you start thinking about what this actually means, if you have a circle, I'm just going to do this with 1. If I draw that real fast, and I just label this, let's say this is a circle, I use A, so let's do X, Y, and Z. If I look at this example and I say I have circle X, what are segments X, Y, and XZ called? Bless you. Read the other one. What are segments X, Y, and XZ called in this diagram? Radius. They're both the radius. What do you know about the radius inside circles? They're always the what? They're always equal to each other. Okay, the radii are always the same. Okay. Now, as you get going this further, what kind of triangle does this make? Isosceles. Good. Which means you have congruent base angles. Okay. So far, so good. Now, if you have congruent base angles, well, let me redo this. Excuse me. If I do this again, and let's say that this is, I'll make this easy, 80 degrees. And what we have? We need a W and a V. I would say this is also 80 degrees. Bless you. No matter what you do, if you've got radii that are the same, which obviously happens in circles. If remember what central angles were? Central angles are angles at the center. If angles are at the center, what would this arc measure then? If the angle is 80, what's this arc in degrees? 80. Right. If this angle is 80, what's this arc? 80. Okay, because you're keeping the same central angle. Now, if you look at these two triangles, are these two triangles congruent?
Oh, well, yeah,
Because they have side angle side, right?
Yeah.
Which means these chords have to be the same because of CPCTC. So now, are these chords the same? Are their arcs the same? That's where a lot of this comes from. Okay. It comes from congruent triangles within circles. If I go back to this picture here, what they're showing here is just a little different offshoot of that. They're just showing that this could also occur if the triangle, if the circles are congruent. Circles are congruent if their radii are the same. If you have two circles with a radius of 4, that means they're the same size. That's where that comes from. Okay? It's just another way of writing this. The mathing that we'll be doing here is going to look a lot like this. This is going to have an 80. This isn't going to have something. It's going to ask you to find it. So if that's 80, these chords are the same. What does this have to be? It's really wordy for some really easy stuff. Okay. All right. For example, I went right back to a single circle. When I'm looking at this circle here, I'll give you guys a second to draw it. Is everybody okay that it's circle K?
Yeah.
So strange things are. Did you get that joke? Bill and Ted's. Strange things are afoot at the Circle K tonight, Ted. It's a movie.
It's an excellent adventure.
Bill and Ted's Excellent Adventure. Have you never seen this? Seriously? You guys live under a rock.
That's what I
It is.
Oh, the circle.
Oh.
Wait, so what was the joke?
The joke is apparently on me because I'm showing that I'm old. Okay. What's that? Was that you? How old do you think I am, Gio?
36.
No.
42.
Somewhere around there, maybe. I'm not in the 30s, I'll say that. I'm like 27.
You're lying.
Of all people to start calling me out, you dear are the quietest person in the room with the loudest laugh on the side. I should.
On the door.
You have to watch Flash through the window.
She said no.
Alright, back to this one here. Notice you have IJ and GH. Those two guys are chords. They have tick marks. The tick marks state that they are congruent. Are we okay with that? Alright. Now, they gave you the measure of arc, arc GH at 100 degrees. What is the measure of arc IJ?
100.
That was tough.
Sure was. I think it's
Alright. Let's do this.
Whoa!
Try and draw a circle and just draw one chord real quick. I know it's tough because you guys are drawing circles by hand. If you want to use a compass, I've got some in the back if you really want to be fancy. That's fine. Alright?
That's why I had
So-
right there. You have square.
Now, purple? Does that have a button? Use a compass. You want to borrow a compass? Oh, it's so hard. Anyway, now I want you guys to see here real quick. You guys agree that this is a chord?
Yes.
Okay. Now, the chord, it goes from side to side. And what happens is, take your pencil after you draw this. And what I want to do is use your pencil as a straight edge and try to see if you can line it up So that way it appears as though it's perpendicular to the chord that you drew. Okay? So mine's on a little bit of an angle, and I'm trying to see if I can make it look like it's perpendicular. Are we okay with that?
I got it.
All right. So what I want you to do as you're moving your pencil across the circle, see how it's cutting the chord into two sections?
Yeah.
What does it appear, just take a guess, to happen when it goes through the center, when it becomes a diameter? What does it look like it does to the chord?
It's like, well, I mean,
Cuts it in half. Okay? And that's the thing. If you have a diameter that's perpendicular to a chord, it always bisects the chord. It's a lot of words for something very simple. If a diameter bisects a chord, it's perpendicular to it. Okay. It's a lot of words for something that, if you look at it visually, it makes total sense. So as you're moving across, all right. Now, there's a reason why this happens. If I draw radii in, what do you know about all radii in a circle? They're what? No, what do you know about all the radii in a circle? What, aren't they always equal?
Yes.
Yeah. So, what's that?
So I was going to say that, but I wasn't going to I think that's.
Well, say it next time. You're not stupid for trying. There's nothing never stupid for trying. Unless you're Yadira.
Oh.
And that's because you made fun of me. I'm joking, Yadira.
No.
Anyway, so what I'm going to do real quick, if I draw the radii in, we know that these two guys are the same. You okay with me on that? Okay. Now, hold on. If I look at that triangle that's created, the large triangle, not the one with the diameter in the middle of it, do you guys agree that it's isosceles? Okay. I'm gonna do this real quick. Okay. Excuse me. So far, so good?
yes.
All right. Now, if this diameter bisected a chord, the red piece that I drew in here is the chord. Are we okay with that? That means those two portions have to be thick part, right?
She just stabbed me.
But Mr. Rush, the middle part right there too, because the two triangles are the same, there's no one cutting out. You know, you're the two triangles.
Now, here's the other thing. Do you guys agree that this chord runs into this arc?
Yes, sir.
Okay. Now, if that chord is cut in half, what do you think happened to the arc?
Yeah.
Cut in half. Now, what about that central angle? What do you think happened to the central angle? Split also in half, isn't it? So we know a whole bunch of stuff is happening. Bisector, it's a perpendicular bisector. It's reflexive with through here. There's, and that's the thing. There's so much stuff that you can do out of this from prior things that we've seen. Right? It's not going to be as messy and garbly gooked as this. What we're going to be mainly doing is, if you've got something that gets bisected, you know it's perpendicular. If it's, and so on and so on. So, and it stems from working with diameters. All right, and that's how this stuff works. So, we do that. For example, all right. Here's another dumb, long, winded one. Draw one more circle. And what I'd like you to do is draw two chords that appear to be the same length. Okay? What I'm going to do is a little bit different. Everybody okay that I drew one chord that's blue? To ensure that mine are the same length, I'm going to clone it. Because I can. I have a button for that. And what I'm going to do is place the other chord. You'll notice that if they're the same length, it's going to take a while for me to get to a spot where they touch the circle the same, like that. Okay? You okay with that? I know that those two chords have to be the same because I cloned them. Got to put my center in. So far, so good? So here's what happens. If you have two chords that are in the same circle, if you're moving them outward, they have to be the same distance from the center. There's no way for them not to be because they're already the same length. Remember, if this one gets placed here, it's not touching the other spot, is it? No, it has to be touching, it's where that, in the same positions. I mean, could this be rotated?
Yeah.
Oh, nuts, I just, All right, yeah, I hit the wrong one. I could rotate this and still place it, I can get it to work. They're still going to be the same distance because of the same length. Now, when you measure distance, how do you measure distance? You measure distance. All right, so if I want to go to the wall, am I going to throw a tape measure straight to the wall? I'm going to measure it to the corner. When you go straight to the wall, we measure perpendicular distance. Remember that? So what happens here is that this distance here is always the same. All right? So if you've got congruent chords, they have to be equidistant to the center. Again, this is going to show up super easy when we get to some of the problems. When we get to some of the algebra stuff, this goes by really, really fast. All right? Notice you're seeing a lot of right angles. You probably see a lot of Pythagorean theorem, and so on and so on. Okay? What's that? If I connect them through, you're right. If I connect them through, I wind up creating I get all these congruent triangles.
I was going to say, with the circle at the end of the coordinate, like outside the circle.
Yeah, if you continue it out there. But then if I put little antennas here, it kind of looks like a butterfly. I was going to go with butterfly.
No, if the circle wasn't there, maybe I would look like, but because the circle's there, hey.
Thanks. I'm almost halfway there.
Yeah, almost.
Okay, let me show you some examples. Which one was it? Oh, I hit the wrong one. I believe I made a copy of this. Let me give you guys a copy of this so you can look at what some of these examples are, so you don't have to continually draw them. So let me get this one to you real quick. Yeah, that's what kind of stinks with a lot of times with a few of these. They get to be a little bit. What's that, Doc? Yes, sir. Chords that are the same length are always equidistant to the center. No problem. I think I owe you one more. I forgot the whole All right, so fast. Here's what's happening. Yes, sir. He needs to run, go for it. So, I would normally like chase after you, but if you make a lap to get some energy, it's cool, go for it. So, real fast, ladies and gentlemen. Guys, as you're going through these things, they're going to ask you to find specific parts. Those first couple are finding the chord lengths. So, what we do is we look at information given to us. And on number one, you'll notice you've got arc CD is 155, arc AB is also 155. If the arcs are the same, what do you know about the chords? So if one of them's 9, what's the other one? Okay. All right. That is it. Now, if you look at 2, it doesn't give you numerical values on the arcs, it gives you tick marks. If you have tick marks, what does that mean? So what is FG? Okay. Like I said, this isn't going to be crazy. Excuse me. KM. Now, this one's a little bit different.
Yeah, so you split it up,
But
you get
it's
5.
it's not on the
Right, but here's the thing. You've got your arc here and the arc here, okay? Now, if you add into this, aren't you adding in the same amount on both sides? Remember how we did that before with like reflexive-ish, if you will? So that means that they're adding into the same part, so therefore the chords have to be the same. So your chord was, like you guys just said, 8.
Yeah.
Same thing goes through when you talk about the arc length, or not arc length, excuse me, the arc measure. We talk about the degrees of it. If you know your chords are the same, your arcs are the same. Are the chords the same in 4? Yes. So your arcs have to be, there you go. 5, they're giving you central angle. Central angle hits an arc. If the angle is 85, what's your arc? 85. Therefore, what's the other arc? There you go. This one is a little bit trickier. 6 is the trickiest, I think, on this first bunch that we look at. Okay. So, how many degrees are in a circle? We have 360 degrees. Now, we know one of the, you guys agree that there's only 3 arcs in this one? We know one of them. If I take 100 degrees out, how much is left? 260. Now, if you look at it, why are you splitting it in half?
Because that's two of the same.
These 2 are the same, very good, which means these have
130. There you go.
There you go.
Yeah.
Again, you know the chords are the same, therefore the arcs have to be the same. How many degrees are in a circle? Take out 100, how many are left? Cut it in half. They go pretty quick. The next grouping, same deal. Let's see which one is this. If it's a diameter, remember, if it's going to be a diameter, it's going to be perpendicular and it bisects the chord. Is it perpendicular and bisecting on 7?
Yes.
Is it perpendicular and bisecting on 8?
Yes. Wait. Yes.
19 equals 20? So if 19 equals 20, I'll give you $19, you give me a 20.
I'm okay.
Fine. Now what about 9?
Yes.
What about 9? Look. But you have 2 angles that are next to each other that create a line that are congruent. What do they have to be? They have to be 90 degrees. Remember, once you get 2 angles that are next to each other on a line, they're always supplementary. Because they make you think.
But I don't like saying too much.
I'm sorry.
Too much earlier to get my friend. I don't say you're losing.
All right. We did, those are easy. Let's see, the last little bit. Let's get to these. The last groupings here are the ones that you just have to do a little bit more thinking before we get to the output. Yes, because even though they have tick marks like that, Sam, they're 2 angles that are supplementary and they're congruent. They have to be. So if I'm looking at here, it's asking us to figure out what BD is. This is the example when I was talking about earlier when you had a diameter that runs into the chord. If a diameter runs into a chord and it's perpendicular, it bisects the chord. So if one side of the chord is 5, what's the other side? 5. What's 5 plus 5? Go. Same thing goes for here. This guy's a diameter, it's perpendicular to a chord, which means it bisected the chord, which means what does it do also to the arc?
Makes it the same.
Makes both parts, it also bisects the arc. So it gives you 55.
I can tell you 13 right now. So what you want to do is you got an LP of 61, right?
Okay.
So that means an ML is going to be 61. So you
Okay.
add those together, once you subtract it from 60, once you get your answer, you get 238. You divide it, you get 119. Hey! Welcome to America.
So if we break that down even a little bit slower,
Did he say 109?
119. Because there's another way you can do that. You look at this. Now, Christian, what you did was absolutely perfect. But I'm going to show you a shortcut.
I bet. Show me the shortcut that I need.
Isn't that a diameter?
Oh,
Is that 180?
you know what? You're right. But,
Well, what you did was perfectly fine. All right?
and now I know the thing.
No problem. Yes, ma'am. Not terrible stuff, is it?
Hold on. The other problem is a measure.
What's that?
A measure. Like how number 8 was.
Yeah, you just got to read it carefully. That's all. No, there's two ways to do it. In this case here, if you use it, it's perpendicular to the chord, so it bisects it. So then you've got your one side of the arc is 61, which means the other side is 61. Ln is the diameter. It's 180 degrees in the diameter. Back out to 61, what are you left with?
Johnson bond in here?
Okay. There you go. What Christian did is he was going around the whole circle. He believed that all those other two arcs, the N and the N, would also been the same. So they would work out this way. All right. So. What? Stop laughing.
You want to have that one?
After one of these yellow and orange,
Taking over my job.
pinky orange,
Good job.
So I wanted to throw those quick examples with you guys so you can see how a lot of this alpha stuff's going to wind up going itself through. Well, because we haven't got the alpha part yet. We have the alpha. So let's take a look at some of the alpha stuff. Now, real fast, what I usually do, we've done this a lot, I take some of the worksheets from the older textbook. This is technically, it's not 10.3, it's 10 point, or 12.2. All right, so don't worry about that. For the most part on here, let's start, we did those examples there. Let's take a quick look at number 8. Okay? Number 8 on this one. So number 8, we have the circle, center, chord, center, chord. We know that they are equidistant from the center and perpendicular, which means what do they have to be? What do the chords have to be then? They have to be equal to each other. So algebraically, you'd know then you'd have to set up the 3x minus 11 is x plus 9. Yes, ma'am.
I didn't get one.
Because we don't like you. So if you look at
I'm trying.
Stop laughing. Yes. This is not a funny laughing matter. Now she can't stop. I'll wait for you to sort. Come on, wait, it's there. It's almost there. It's going to. There it is! You guys just dread. You guys just dread coming here sometimes, I would imagine. Let's see, that was this. Those are easy. Evens. Do all the evens on both sides. Call it that. Do all the odds then. What else?
I like the evens. Yeah. Actually, no.
It doesn't matter. So,
You already did the evens.
right?
Bro, I just circled the high.
This should be pretty easy. Okay, this should be pretty easy. Then we'll see how we do on this one. Maybe tomorrow what we'll do is there are other styles of these sets of problems that you can do a little bit more of Pythagorean theorem on and whatnot. I think that's what we'll hit for tomorrow, and then that way we don't have to start doing the inscribed angle stuff on a Friday. I think our quiz. I thought the quiz would go Tuesday. Maybe it'll just be Wednesday instead. No big deal. No big deal. We got plenty of time to get through. Once we get through this first quiz, there's technically only 2 sections left to finish out for the chapter, which those are the 2 sections that take the longest. So between those 2 sections will take us probably 5 days, and then that puts us to our test still probably on that Thursday before spring break. All right. We knock out the evens out of this stuff, and we'll go. Yes, sir. Like 2.5 weeks or so.